Yes, Mike.
Yep, great stuff. Okay, right. My name's Mike Andrews. I'm called DWG Infraco Limited, part of the S&C Alliance. I've got 30 years of railway experience, having started as a techie on East Coast Main Line back in the 90s. I've just been recently upgraded to a fellow within the PWI after being a member for 30 years as well. So I highly recommend that everybody contributes as much as they can to the organisation, because it's great at knowledge sharing and developing the future railway engineers. Okay, so what we do at DWG is we provide polyurethane life extension products for railway timber and concrete. So that's spike fast for railway sleepers and fast patch or spike fast for timber sleepers and fast patch for concrete sleepers. So we'll go into that in more detail in a minute. My presentation. Right. So as Tim introduced us, today is all about the S&C Alliance, and the S&C Alliance is a collaboration of 6 companies: Intel Rail, Stay-Tight, Connex, Flexilube, ourselves, and Interflon. And that schematic sort of highlights the areas of interest for what people do. Intel Rail, no particular arrow pointing to anything, because they do everything, as they are the implementation part of the S&C Alliance. So they will be the guys that come along and actually physically undertake the work. So we'll go into more detail with each of those as each presenter skips along. So, quick introduction. I don't know whether any of you guys are familiar with Spikefast, a polyurethane material for fixing timber sleepers. Whoops, I skipped on too many. So the simple description of it is you take your screw spikes out, you fill the hole with the Spikefast as is indicated in the methodology on the pictures there. The hole is completely filled with Spikefast, and after 20 minutes you just drill it like it's new timber. It's a far more effective way of extending the life of timber than using wood plugs, and offers great accuracy for track regauging, as when you're using a wood plug the drill bit will tend to bounce around, but on using Spikefast, wherever you put the tip of the drill in, you will get the hole in exactly the right place. So perfect for regauging work. Now, the other type of Spikefast that we have is a low viscosity variant, which is used for chair indentation, as in the pictures there. As you can see, the top 2 pictures, there was some indentation on some S&C bearers at Buxton. Indentation 5mm in the forefoot to 35mm in the SAS, and somebody wondered why they got wide gauge there. Same process as you would use with the ET75 material, the thick stuff, except this stuff will flow and self-level. So as you can see from the bottom pictures, we've used a couple of cartridges of material to fill the indentation. It sets within 10 minutes. After 20 minutes, drill the screws back in, fix everything down, and it's job done. So it is as easy as that. Also, on longitudinal timbers, Spikefast ES50 has been used numerous times for filling the voids on wheel timbers. And you can see this is up in Cumbria, wet weather. The holes are all filled with water. You can use this material in the wet because it's denser than water. So what you do is you just put the mixing tube into the holes, apply the material, it expels the water, and because of the exothermic reaction, the product dries the hole out, and again in 20 minutes you can re-drill it and fix it. Onto our concrete products. Fast patch LV, low viscosity concrete repair material for fixing screws and fine cracks. This is some recent work that was done on the Elizabeth line. they had problems with Excalibur bolts pulling out with Vargel nuts on. So we went down, filled the hole with some fast patch LV material, dropped the bolt back in, sets in 10 minutes. After 1 hour, we put a pull test on it, and we got a 6 ton, which we held for about between 2 and 5 minutes at the end of it. And the bottom photographs just show the holes drilled out, plastic dowels drilled in, dropped into the fast patch LV, and a cross section cut through it, just so you can see that the LV has completely filled the area that needs repairing. Fine cracks on bridge decks and railway sleepers, G44s with cracks emanating from the rail seat housing down at Reading. That was repaired just after the Reading remodelling project. Final product, CTR 100, which is a rail seat abrasion repair material. As you can see from the photograph, if you get indents where the pad has deteriorated and the rail starts to eat into the bearers and the sleepers, which can cause reductions in tow loading, and potential, if it gets bad, you could end up with a rail roll. This was a job done recently down at Lewisham. As you can see, a little bit of indent in the photograph on the left-hand side. The indent went down to 18 mil. So when I went out with the tech, sort of put the cross level on, and it was showing an 18 mil cant on the end of a modular bearer, and that was just the indent that had eaten its way into the bearer. Highly critical freight route going through London. The material is applied through cartridges similar to the Spike Fast material. That photo is not of Lewisham, that comes from the US, because I didn't have a photo of the guys actually applying the material at the time. But the right-hand picture, you can see the CTR material applied on the rail seat. So that's just waiting to cure, which can take about an hour before the rail seats are applied. And then it's just repadded, rails back in. And the photo, it just gives you an example of an indent repair that was done for demonstration purposes. Greenhill Junction in Scotland, same sort of problem. The S&C bearer under the crossing had deteriorated to the point where the rebar was exposed, and the repair was carried out and took just 90 minutes from start to finish until it was clipped back up, and the speed restriction was taken off it immediately the next morning. So that's skipping through there. They're all very brief, our slides today, because there's obviously a few of us. So trying to keep it brief. And if you've got any questions for me at the end, feel free to ask. Now I'm going to skip now to the Intel presentation, which I've got to do because there's nobody from Intel Rail here today. So just bear with me while I flip that across. Right. Okay. No, it's not going into presentation mode. I'll skip through anyway because time is of the critical essence. So Intel Rail, as I've said before, they're the delivery arm of what goes on within the S&C Alliance. So they're the guys with the PWI experts, boys on the ground, and the S&T experts as well. They've got a wealth of experience within what they've learnt. Darren Sharp has worked a lot with them, as has Neil Denton. So they are very skilled in being able to deliver various problem-solving solutions to do with S&C. So without reading all their their text and what's on there, but as I say, they provide a unique specialist service for keeping S&C reliability. What they can do is right from the get-go is participate in a scoping exercise. They can do a condition report on what is required and what is needed. Then as a sort of a collaboration between all of us, if there's any specialist stuff that is required that we can contribute to, and then a plan is put together, giving the client information on what the problems are and what the solutions are to keep things moving along. So as is on the slide here, it's happy to engage with the client on various different things, point care principles, improving reliability, and making sure that everything is installed correctly. Various different high-level business strategies, review failure history, visual inspection records, observations, significant recommendations, and undertaking the work to make sure that everything is carried out as per Network Rail standards. Reporting, as before, Network Rail standards forms, the TEF forms, etc., that Neil Denton's developed, will be used as part of the reporting process. And it's one of the things that we say as sort of as a collective is that we would quite happily like to talk to anybody within Network Rail about their golden assets, so that give us your worst failing points on the network, and I'm sure that collectively we can come up with a solution. And I think we'd all be honest enough to be able to put our names against it and say, okay, we'll give you a guarantee that what we suggest will work. So that's the challenge to you, and that's our challenge. That's the contact details, and as we say, this information is going to be made available at the end of the presentation. So I'll now hand over to Andrew from Intel to skip through his bits. Andrew from Connox, I mean, sorry.
Thank you, Mike. Okay, hopefully that's now showing for everyone. So good afternoon, everyone. My name's Andrew Turner, and I'm an account manager in the UK for Connox. I've been with the company for just under 2 years now. But prior to that, I was an engineer at Network Rail. Most of that time was spent in the technical authority focusing on S&C. So I've now sort of moved across to Connox, but utilising some of the experience I learned in that role to help Connox progress with our solution. So
Andrew,
what was Connox?
Andy, you've got some issues with your microphone.
Are you struggling to hear me? Ah, okay.
Like a reverb on it.
Not sure why that is. It's still doing it.
Yeah, you can still hear you. It's just not great, but you are legible.
Okay, I'll try and push on it. It's on the right microphone, so I'm not sure why it's struggling. Try changing the setting. Hopefully that's better. Okay, so moving on. Connox's role is
It's actually worse. It's got worse. Sorry, mate.
Worse. Okay. How about now?
That's better.
Okay, we'll go with that. Great. So here today to talk to you about Connox. So Connox's role is to provide decision support tools which enable predictive and preventative maintenance regimes for S&C. So we do this through a system we call Holistic Switch, which is something we're now bringing out this year. So we speak with a huge number of rail engineers, both in the UK and around Europe, and most of them say the same thing to us, that managing S&C holistically is crucial to improving performance. So that's taking account of not just a single data source in terms of what the condition of the asset is, but bringing in multiple different data sources to help understand what the root cause of any potential failures are. So by focusing on just a single measurement type, many of these defects will go unnoticed. So a truly effective system has got to take account of a combination of these different insights, which is where we're moving our product to today. So our system is based on combining data from our IoT devices, the little yellow boxes you may have seen before, which are installed at both switches and crossings. And these monitor the track bed and railhead condition for both voiding in the track bed and the level of impact force that's being applied to the switch on the crossing. And we also align that with existing RCM data that's been around for around 20 years in the UK from point operating equipment to provide this holistic switch system. And this is what enables us to detect such a broad range of defects. And by taking this holistic approach, a much larger proportion of S&C defects become detectable, which then enables a more robust set of business benefits. Because once you can detect more defects, you can act sooner, which means you can then reduce failures and subsequent delay minutes. So, as I said, the backbone of our system is this IoT device, the little yellow boxes that you may have seen before. These get installed either at the switch toes, just ahead of the switch toes, or in the crossing area, typically on the crossing nose bearer. And you can install them at either location, both, or just one or the other. It's really down to customer preference. They've had full product acceptance in Network Rail for about 3 years now, and they're designed to be a fit and forget system. So once they're installed onto the bearers, there's no wires, they're fully battery powered, and they record all of the data for traffic going over the site wirelessly, which is then sent back to our cloud-based system each day to then provide the insights to the local engineers who want to understand the condition of their asset. And that asset condition data is available from the day after it's installed in this web-based user interface. One of the benefits of moving to a cloud-based system rather than sort of bespoke software or on-premises solutions is that we can provide regular updates and new features to the product without any kind of requirement for the customer to do anything on their end. So we're starting to do that now. We've got quite a few exciting new features that are coming out this year that if you want to find out a bit more detail, I don't have time to talk about today, but feel free to speak with me afterwards and we can discuss those. In terms of coverage, we're now installed in all 13 Network Rail routes. We have large rollouts, particularly in West Coast South, Wales and Sussex. And in Sussex, we've worked really close with them, in particular to embed the insights that we're providing into their business processes, such that the use of the data is now becoming BAU in these areas, which is really the best way of unlocking the biggest benefits. You can have all of the data you like, as I'm sure everyone's aware, but it's really about how you apply that to your existing business processes to see the benefits. And that's often where we've stumbled as an industry, I think, when we bring in new technology, how we embed that into the process to see the benefits. So once we start to take this holistic approach, a number of different use cases can be developed. And these are designed to tackle the key issues that you'd face in management of S&C today. So for instance, track bed health and crossing health can be determined through analysis of the acceleration data that we get from our little yellow boxes, the IoT devices. And PWI health is determined through a combination of both the acceleration data we have from devices installed at the switch area and the existing RCM data that I already mentioned. So we combine those two data sets together to help the engineer understand what the root cause of any issues is. And we're designing the system to be capable of ingesting data from multiple sources, so not just those ones. So as an example, later on this year, we want to integrate track geometry data into the system, as that's an important part of understanding the condition of the asset. But also we're working in partnership with people like One Big Circle to introduce downward facing imagery to the system so that you'll be able to align both the visual insights they're providing from their system with the data insights that we're providing from our accelerometer. So for instance, you might be able to identify a squat in a crossing nose from the visual data, but we could align that with the acceleration data we're seeing from our device to confirm that. So our interface combines all of these insights in one place. So whether you are a signaling engineer or a track engineer, you can get this clear understanding of why your asset isn't performing as it should be. And this supports you in identifying the root cause of potential problems before they become a service-affecting failure. So you can see there on the right, an indication of how the interface looks. We'll start to give you indications of where you've had acceleration increases at a crossing, for instance, which is indicative of potentially a railhead defect that's emerging. But then we can also look at switch areas, the acceleration data in that area combined with any insights we're seeing from the point operating equipment analytics, which I'll talk through in a second. The idea is it's all combined in one location, so you're not fighting internally in terms of what the root cause of the issue might be. So moving on to point operating equipment health, How is this different from what you have currently? As I said, the RCM data has been around for 20 years now. So what are we doing differently? But we can diagnose emerging failures by undertaking trace level analysis of each swing. So we look at each swing specifically. And we're no longer constrained by the high level metrics such as swing time or average current that's typically used today. And indeed, many of the failures we've observed were not apparent on these existing metrics. So our detection algorithms can identify the behavior of key PWI failure causes, such as tight locks or frictional or roller effects on a trace by trace basis. And the alert system is highly contextual, so it doesn't rely on alarms on absolute values. We assess the historic condition of each of the assets, and we automatically create reference curves unique to each of those assets. And by comparing this with all of its peers, we're able to highlight only those cases where an intervention is necessary. So it's really about targeting your maintenance effort on the assets that definitely need the work. So just moving on to a couple of brief case studies. So this is focusing on where we've had data from the device installed on a crossing nose. So the chart on the top right indicates an acceleration profile over time. So as you can see at the start, it was running at around 6.5 G, which is generally above average, quite high already for a crossing. But as you can see, over a couple of months, it started to progress significantly higher, up to a peak of around 10 G. And at this point, an inspection was undertaken by the local team, and they saw this quite significant breakout on the wing rail, which left unchecked may have resulted in a more catastrophic failure like a crack. But because they were able to diagnose this relatively early, they were able to go and do a weld repair, grind it back. The acceleration then dropped back down to a much more typical 3 or 4 G, which is what we'd expect from a crossing. And the asset was effectively saved from potential trap closure and expensive renewal. One more case study around the point operating equipment data. So the chart on the top right is showing our representation of failure score for this particular asset based on a tight lock failure we could see emerging. So the y-axis here is an indication of how likely we think a failure is to occur. So as it gets closer to 1, that's the point where we think a failure is imminent. So in this case, this failure metric was increasing for around 3 months prior to when the failure actually occurred, which was around June time at the absolute peak. The key thing here is that our system was showing this emerging for those 3 months from the data we're already seeing. But if you just looked at the existing RCM metrics like average current and swing time, these were completely flat through this period. So if you were focusing on what you already had, you wouldn't have been able to predict this fault. Whereas our system, by looking at the individual traces and comparing them with their reference curves, we were able to see that there was this emerging fault that was likely to take place. In this case, it was a thermal issue. So this took place in the summer when the track had warmed up significantly. And it was at switch diamonds. So it's a kind of classic failure we see at switch diamonds in the summer, but we were able to predict it beforehand. So just to wrap up on summarising the value proposition, it's really aligned with the challenges Network Rail and other infrastructure managers are facing today. So by targeting maintenance more effectively and ensuring that maintenance staff are only going to the sites that they need to, we can reduce the amount of reactive work that's taking place. And that fundamentally just reduces boots on pallets, which is a key requirement of the industry going forward. And we're also able to assist in remote compliance of standards. So for instance, in the newest version of TRK 1054 for crossing inspection, there's a requirement to inspect the amount of voiding that's at each crossing, and obviously our device can do that as part of its core functionality. And then really around delivering on-time railway and efficiency, if we can reduce the number of infrastructure failures by managing the asset more effectively, we're always going to extend the life of key S&C components, and that's going to give us the efficient and on-time railway that we're all striving to achieve. So that's it for me. Thank you very much. And I'm going to hand over to Rob from Interflon.
Thanks, Andrew. Okay. Share screen. Can people see my screen?
Yep.
Cool, brilliant. Okay, so my name is Rob Taylor. I work for Interflon. I've been working in the rail industry now for the last 18 years, looking after Network Rail, London Underground, but also supporting international projects as well. So a little bit about Interflon. This is traditionally what you would normally see out in track. This has been used for generations, traditional black grease, oil, etc., which is a nightmare when you come to do inspections of the S&C, because it covers up a myriad of issues. Traditionally, as I say, that's the top that you would normally see. Interflon's technology is very, very different. So we work on a dry film transparent technology, which is manufactured in-house. So when you physically go out there and do track inspections, you can see exactly what's happening on the slide shear surfaces, etc., and throughout the switch. Like I said, the product is manufactured in-house. It's a unique technology to Interflon. We call this technology MICPOL, but effectively it fills in the asperities in the metal surface or even plastic. It can bond to any material. And then we use a polarization method to actually get it to stick to the substrates. This actually bonds very, very well in any orientation, vertical, horizontal, etc. And even in wet weather conditions as well, it still bonds to the surface. The technology helps metal-to-metal contact, which you obviously get at startup of any switch movement, etc. It also repels weather, so once the coating's on there, ice physically cannot stick to it. It's also UV resistant, and it reduces friction to a minimum for quite some time. So the product was originally developed for the Deutsche Bahn, and the scope was to develop a dry film, all-weather transparent lubricant that would improve performance and reduce failures. It took about several versions before we got the version right. It was introduced back in 2008 into Network Rail after the West Coast Main Line had gone under a £9 billion upgrade. The high-speed switches known as the high drives were installed, and these were failing. So Interflon was approached to see whether we could look at some of our technology to help with the situation. So the testing was conducted over several performing assets to prove the product's benefits. With it being a complete technology change from wet lubricants into a dry coating, the testing was done by their own internal engineers. And this was done over a 2-year period with all the senior engineers within Network Rail. And this is typically some of the data that you could see during and after the trials. So as you can see with the top graph here, you can see the failure data, and Interflon was applied, and effectively the failures disappeared completely. Likewise, the bottom graph, these were high drives. The blue line was showing the asset failures on the number of assets that was installed. The yellow line here was showing where Interflon had been applied, and you could see that the actual asset failure had started to drop. So again, showing the benefits of using the product. This is typically a high drive, high-speed switch on the right-hand side. And this is typically, as Andrew mentioned, some of the RCM, remote condition monitoring information. And what this measures is it measures the initial inertia and startup of the switch, and then it measures the actual transit time before you actually get lock and fit up. The green line is the reference prior to using Interflon, and the blue line is after using Interflon. And we can typically knock between 30 and 51% off the power needed to throw the switch. So again, shows it's a very good low friction coating. This is some service affected data from Network Rail. Again, the blue line predicts the failures on assets that are not treated with Interflon, and the red line is assets that are treated with Interflon. So we can take failure away just by using this particular product if there's no underlying issues as such as defects, etc. But what is interesting is we've actually got two bumps here in the actual data. When investigating to find out what would cause those failures, the engineers came back and said that they'd actually run out of product. So it just shows when you stop using the product, the failures do come back. Again, does it have an effect on mean time between failure? It has a big effect on mean time between failure. Again, you can see the benefits there in the graph. An example coming from Bristol Delivery Unit. Again, they started to convert their switches over a period of time. And what they found was they had £1.3 million saved in Schedule 8 failures. Again, a significant payback after using the product, and an 80% reduction in point failures. FreeAg also did some data for Network Rail. They used traditional molybdenum coatings on their slide chairs, which is a very low friction coating. And again, what they found after testing, that obviously after 20,000 cycles, you can actually see switch cycles. You can actually see the deterioration on the molybdenum. With Interflon's coating on top of the molybdenum, that surpassed 20,000 switch movements, right up to 70,000 switch movements, and the coefficients of friction almost stayed the same. So it's got a lot of longevity to this coating. And if we can put some sort of references to the friction level that you do get by using the coating compared to molybdenum, the line on the left there is where Interflon's coefficients of friction would be on top of molybdenum. London Underground also did some testing. They did some testing with rollers to see what the benefit would be with using Interflon with rollers, and also without. It says here the only variable was that the minimum air pressure required was reduced from 47 to 32 psi for the Interflon only, and from 47 down to 24 for using rollers. So obviously rolling friction is much lower than sliding friction, but combined, if you put rollers and Interflon together, you can actually bring that down to 20 psi. And again, rollers are an excellent product, but they can only go through the head planing length. They can't go to the heel section. The heel section is critical to get lubricant and get your low friction coating in there, particularly on long switches, and that's where Interflon benefits. Also provides a significant lift between the head plane length, which is what I've just mentioned here about rollers, etc. We also do coatings for the switch machine as well. And again, typically, and this is a HW machine, you can see the graph there on the left. You can see a before and an after since using the Interflon product. And again, this is a dry coating. We've also developed a product for switch blades, because traditionally you're 3 dabs of grease and then the flange of the wheel from the train pushing the grease through the switch blade itself. Doesn't lend itself ideally to get full lubrication across the switch blade. So we've developed a dry coating, which is again transparent, but you spray it all the way through the head planing length of the switch. And again, it offers some big benefits to reducing SO53 weld repairs. Again, Derby was a big test site for using this particular product. And again, they over a 2 to 3 month period, they actually decreased their failures down to almost zero. And again, there's some data here from Doncaster. Doncaster has a lot of S&C on the East Coast Main Line, and you can clearly see a before and an after of using our particular product onto the switchblade. So back in 2018, the area had 300 weld repairs, and the longer they started to use the product and over more assets in 2020, 2022, they'd actually reduced it from 300 down to 13. And again, you can see the other data there on the screen. Network Rail have produced a reliability improvement alert called RIA 34. If anybody is on here that has access to the RIAs, again, all the information is in there, including all the business case and benefits. So there is a reliability improvement alert out by Network Rail. There's also a comprehensive book here. So the one on the right here is a comprehensive book outlining all the approved assets, the procedures, how to change over to Interflon. But again, there's a lot of data there from the independent engineers using the product. Again, that's readily available from ourselves, which we can send out to you. And finally, what I'm going to show you here from Interflon is the gentleman on the left is applying the dry coating to the switchblade, and the gentleman on the right is applying the Interflon product to slide chairs. This product also resists sand adhesion, which will be shown in the end of the video. But if I just play this now. So hopefully that's showing you exactly how you apply it. It is very important to apply lubricant to the heel section. That is one of the critical parts for switch movements. So again, showing you in an upright position, using a backpack, a metered amount, 1 teaspoon per slide chair, and that does the job. Self-spreads and dries to a dry coating. And again, at the end of the video, it showed you that it could resist sand contamination immediately after applying the product. Okay, so if we're going to FlexiLube's presentation now, so this is typically what you would see out in track. So these are single point lubricators that fit onto assets where you need lubrication. So as you can see here, you've got them on the clamp lock bodies and also on the cranks as well, on the 7/8 pins and the boss. So Bletchley DU was challenged to beat their target of point asset failures by 20%. And they started to train all their staff how to install Similubes. And what a Similube effectively is it's a vessel that holds grease or oil or coatings, and it's got a timer device fitted to the top. Once you turn that timer device on, they're always set to 12. It then produces hydrogen gas at 5 bar and starts to push the plunger out, and then actually sends the lubricant out at the desired quantity over a certain time. So if it's set to 12 months, it will dispense all that within 12 months. After doing all the installs in the Bletchley area, did it work? Well, they actually went from 28th mean time between failures on their clamp locks now to 7th. So again, it actually shows you there that it really did work. Similubes were fitted to cranks to reduce seizure and blockages of grease paths. Anybody who's been out there to lubricate cranks, you tend to put the grease gun on and you almost get resistance straight away. That's because grease is plugged. Grease doesn't like to be intermittently lubricated, because what actually happens is the oil bleeds from the thickener and then it produces a plug. By using Similubes, you constantly keep the grease moving, so it stops any of the grease paths from being plugged. You can also refill these lubricators as well, which is quite unique. So instead of throwing them away into waste stream, you can actually put them back into service, send them back to the manufacturer. They'll recheck them, regas them, refill them, put new stickers on, etc., and they're ready to go. Since using the product, the area has not had any seized cranks at all. Again, it can also be used in road rail crossings on the barrier pedestals. Anybody working on the barrier pedestals, there's a lot of faff to actually get into the barrier pedestals. The greaseways are actually fitted quite high up into the pedestals themselves, so it's a case of getting in and getting a grease gun to them. Again, by fitting these lubricators, it will lubricate the whole of the system for a period of 12 months. And that's Alex's presentation. I'll now pass over to Joe.
Cheers, Rob. I'll just share my screen. Hopefully everyone can see that and hear me all right.
Yep.
Yeah. Cool. So, just a quick introduction. So I've been at Stay Tight for just over 2 years now. So I've been working with within the rail industry. So our job and main role is to bring solutions for fasteners within the rail industry. So especially with fasteners that undertake quite a lot of vibration. So what's the purpose of a threaded fastener? What are we trying to achieve with a threaded fastener? So essentially what we want to do is create bolt load within the bolts. We want to stretch the bolt, which in turn gives the joint a clamp load. So the joint's actually pulling itself back together. And the job of the nut is to essentially keep the bolt in its loaded state and thus holding the clamp force in place. So as you start adding tension to the bolt or adding load to the bolt, you'll take it through what's called its elastic range. So to start with, the bolt's nice and happy. It'll start going through its elastic range to start with, and then you'll hit a yield point. Once you start going past the yield point, essentially what you're doing is you're damaging the bolt. So you're taking it past its elastic range through the yield point, and then up to its ultimate load. If you keep taking it any further and further and further, you'll start to damage the bolt, and then eventually it'll start to fracture and will snap and break. If you do take a bolt past its yield point, you need to take the bolt out, throw it away, and replace the bolt. Why does loosening occur? So obviously you've got your vertical forces, horizontal force, and rotational forces. Especially within an industry like the rail industry, these sorts of forces are going to be taking place all day, every day, on regular cycles. So it's imperative that we get a solution, a nut that can hold a bolt load and a clamp load in place. You've also got in-service conditions. So the main ones that we like to concentrate on here is vibration and corrosion as well. So one thing we're trying to get across to Network Rail especially is that, we're using a zinc-plated fastener. Why we're not using a zinc-plated bolt? Because as soon as corrosion starts to take place, as you can see even on these bolts here that have been stored in our warehouse, you can see the orange rust and corrosion. So that's going to start to affect the performance of the fastener as well. So if we're using zinc-plated nuts, we might as well use a zinc-plated bolt as well. So the product we introduced into the rail industry is the hard lock nut. You guys might have seen this before. It's a two-piece locking nut, and unlike most conventional prevailing torque nuts, it doesn't rely on deforming the threads to actually lock. So a bog standard prevailing torque nut, such as a Wren lock or a nylon insert nut, you're applying a high level of torque to actually overcome the threads and deform the threads to lock it in place. So it works based off the basis that if it's hard to get on, then it's hard to get off, which in theory sounds like a great theory, but it doesn't actually work. So with the hard lock nut, it's a free spinning nut, so I can spin this up and down the threads just using my hands. And if you've got no threads and you put the nuts together, you'll see that they can close right up. Whereas if I start to introduce some thread onto, start to screw onto the threads, you'll see there's a gap in between. And you can see that on the diagram in front as well. That gap's created by the bottom. The bottom nut has an eccentric cone on. I don't know if you can see that on the video or not. But essentially, one side of the cone is actually thicker than the other, so it's slightly offset. So when you start applying the top nut, it pushes the top nut off center. So what allows a fastener to come loose essentially is gaps within the threads. So when the two main parts come together, you've got gaps in between. When that dispositions the nut off center, you're closing them gaps up. So it doesn't allow for the movement within the actual threads for the nut to work its way back up. So this is a Junkers test comparison of a full nut, a nylon insert nut, and a hard lock nut. So you can see on the graph on the bottom right, the blue line is the hard lock nut, the red line's the nylon insert, and the yellow line is the full nut. So as you can see, just in the time of me speaking, the full nut's already worked its way completely loose. Nylon insert nut is now finger tight, so again, that will just start working its way loose. And the hard lock nut has had its settling embedment loss to start with, but then has stayed at a consistent clamp force. So you'll normally see within your first 2 weeks, your settling embedment losses will take place. And then after the 2-week period, then it'll sit at a constant clamp load then. The hard lock nuts are also completely reusable. So again, with most prevailing torque nuts, you're actually deforming the threads for them to actually work. So once you've used that prevailing torque nut once, then you're going to have to get rid of it, or you should get rid of it and put a new one on. Now we know from practice that this probably doesn't take place as much as what it should, which again is worrying because the actual locking system is deformed and broken. But you're having to keep increasing the torque value to actually get any sort of deformity on the threads to actually make it work. So the hard lock was first introduced to Network Rail and approved in October of 2003. Now, unfortunately, these weren't actually made part of the standard until after Potter's Bar and Grey Rig. So it was then made part of the standard that every single adjustable stretcher bar would have hard lock nuts installed on them. Now to a more recent application, the fish plates. I'm not going to go too deep into this because I know Rob's just sort of spoke about his lubrication process, but these work essentially hand in hand with the interflon lubrication. So again, it's 4 hard locks on each fish plate, and there's also a conical washer in there which takes out the settle and embedment losses. So your general maintenance cycles, the red line shows the current maintenance cycles with the Renlock nuts. So you can see the clamp force drops off, and then once a maintenance cycle takes place, it increases, drops off, increases, drops off, increases. But you'll notice that after every single maintenance cycle, the clamp force never actually returns back to its original value. It slowly starts degrading, and that's because of the degradation of the actual nut and not being able to actually deform the threads any further. Again, so there is a 4-step process you can take in actually upgrading the joints. So you can do 1 in every 4 joints, or you can just do the full lot in one go. But again, I won't dive too deeply into that because I know Rob's already touched on that one. So we've actually taken it 1 step further now. So we've started introducing intelligent bolting. So again, going back to the actual bolt load and the stretch of the bolt, we drill through the center core of the bolt. But it's not as scary as it sounds. It's only about 1% of the material, or just less than 1%. And then we actually put a strain gauge pin inside. So the strain gauge pin and the sensor just underneath the yellow cap measures an elongation gap. So that elongation gap, as you start to add the bolt load to the joint, will actually stretch that gap and open it up. And then through a series of calculations, we can actually then work out the clamp force as well. So then that data then feeds through in increments to the gateway, which then feeds it through to your desktop, your laptop, your phone, or a tablet that we can also provide. So you'll see, sorry, just going back to this one. So you'll see on the picture on the left, there's an LED light as well on the front. So when you actually scan a magnet over that, that will then activate and start to flash, as you can see on there. So these ones are set to blue is loose and white is tight, which is what Network Rails asked for. So we started to wonder where we could actually use this technology, and we could actually use it in temporary rail clamps. So currently, somebody has to go out every single day and check a temporary rail clamp still in situ. Through this technology, if you know that the bolt load and the clamp force is still there, then the temporary rail clamp will still be in situ. And then the information that's then fed through to your desktop will look something like this. So you'll have minor, unknown, and major alerts. So the minor alerts are when it falls into the yellow area. Major alerts when it falls into red, and what we call the Goldilocks zone is in the white section. So once that once one of them actually drops into one of those and you get an alert, it'll go through to the first person. If the first person does nothing about it, it'll go to the next person, and so on and so forth until somebody acknowledges the alert. So you'll see the data on the screen is what you're shown. So you get a date and time stamp, you get the bolt load, and you also get the bolt temperature as well. Because obviously bolt temperature is important due to expansion and contraction of the joint. So you'll see from the data on the screen, you can actually put a maintenance cycle as well, which is what that little M is. So every time you do a maintenance cycle, you can update the data to show that as well. And you'll see each dot on here is a timestamp, and then you can start plotting that then on a graph, and you can see any trends, patterns, anything like that. So the one on the screen that's showing now is a joint that's currently over in the US, and this was actually fitted with hard locks, and you can see the clamp load steady state. It has fell into the yellow section, but that's because we believe that the actual torque and bolt load weren't actually high enough to begin with, so it's just dropped into that yellow zone. But again, this is data that we can now see, and we can start making recommendations as well in terms of increasing torque values. And that's everything for me. So if anybody's got any questions, I look forward to hearing them at the end, and I'll pass back over to Tim.
Well, first of all, thank you very much to all of our speakers today. So thanks to Andy, Mike, Rob, and Joe. I guess I'll open it up to the floor. A lot of the questions that have been asked in the chat have already been answered. Mike, do you want to add a little bit more regarding the wheel timber splits cracks for Spikefast?
Yeah, hi Tim. Yeah, it's it's something that's been a contentious area. I was just looking at what it said on the original PA certificate, and it does specify use for longitudinal timbers. It has been back in 20, I think it's 2014. We did some work on. We were asked to supply some material for Chelsea River Bridge down in London because they got problems with voided and split wheel timbers, and they had to get, I think, 6 months out. Oh no, 2 years out of it because it'd been kicked out of the budget. And we supplied them a load of ES50, which was just flooded into the holes. It filled all the voiding and the splits and stuff like that. And tie bars were removed as the integrity of the timbers was returned, and these were finally removed in Christmas 2022. So they got their 2 years and some out of it. And I actually went to Whitemoor Depot when we tracked down where they'd been taken to after they'd been removed, to do some bit of chainsawing on them and have a look at them. And the spike fast and the rail seat areas were still fairly solid and I'd imagine holding a certain level of integrity. The rest of the timbers were sort of virtually shot, but yeah, it had done its job, and which is life extension material. But yeah, it is a point that gets raised from time to time. People say that you can't use it for this, you can't use it for that, but willing to have some more discussions with whoever to sort of put it to bed once and for all.
Thanks, Mike. And then Stuart Corrie, you asked a question that Rob has answered. Just wanted to make sure that was the answer you were looking for. Was it regarding how much the lubricant cost, or was it slightly different?
Oh, thank you for your answer, Rob. It was mainly based around the entire costs, because it's very easy to spend money to reduce the amount of Schedule 8 payments, but what I was hoping to get at, though not hoping too hard, was to get whether or not the total save was more or less. Oh, because there's also going to be a bunch of labour and so forth on that as well, isn't there?
Sure.
Thank you for.
No problem. It was a lot less. Dan Collins, if you want to look on the system, he's the guy to speak to. But the other thing I forgot to mention was that traditionally they were lubricating twice a week, and with our products, they've now managed to get up between 6 or 8 weeks. So they're having to send people out less often, and it only now takes 30 seconds to lubricate a switch, where before it was taking many minutes.
So overall, you're actually spending less.
Yes.
To achieve the same performance, or save better performance.
Yeah.
Thank you.
No problem.
Great, thanks, Rob. I haven't seen any more questions that haven't been answered in the chat, or there's a new one just popped up. So question for you, Rob. Interflow charts talk about benefits using lubrication in Bletchley. Do you have any current stats on the benefits of using Interflow?
I've actually just asked for some more stats from Doncaster. I've not had them back yet, but I understand that when speaking to the guy who normally gives them to me, he said that the results were still very good. However, modernising maintenance is now trying to push out the frequency and potentially beyond the product's capabilities. So again, there's some buffer in there trying to find out what the frequency should be compared to what they would like it to be. But most of the routes I'm talking to now are still happy with reliability.
Thanks, Rob. Susan, does that answer, or is there anything you want to further ask? I'll take that as a no. So we've got 1 minute left. Are there any final questions before we close the session from the floor? Anyone wants to put their hand up? I will take that as a no. We are all at Rail Live next week, which is coming around very quickly. So yeah, please come and see us. We do have one marquee between us all, so we're all there to answer any questions, do product demonstrations, and talk around what it is we are offering to help, I guess, achieve reliability and efficiency of maintenance of S&C. So please come and see us. Thank you very much everybody for the time, and obviously try and dial in 2 weeks time as well. And on that note, I will close the call. Thank you very much everybody.